Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Well, Houston, we don't have a problem. Today we're going to talk about something called the normal force. What's so normal about forces? It's easy, actually, and we're going to figure it out as we go along. So let's just think about a case example. Let's say we've got an apple that's free falling to the earth. Let's draw the free body diagram. I think that's an apple. So what must be happening if I draw the free body diagram? That the force downward, the force of gravity, is downward, right? There's one force acting on it. The apple, pardon me, is falling freely. But what about an apple that's sitting on a desk? This is the tricky one. Well, we have the force of gravity, right? But since it's not moving, there must be a force that's stopping it from moving. It's not accelerating, right? Actually not accelerating. Then I need to have, if you will, the force of the desk pushing up. So it has to be equal and opposite because the apple is not accelerating when it's just simply sitting on a desk. So let's think this through. Gravity, of course, is acting in both situations, but there must be this second force acting on the apple. How do we know? Well, remember Newton's second law, the F equals ma. The apple is sitting on the desk is not accelerating. So the net force must be 0, right? So for the net force to be 0, there would have to be a what? Think about this. Equal plus opposite force acting on the apples that is keeping it for a second. This is called, big fancy, this is called the normal force. Now, the word normal has to do with angles, right? Remember that all forces come in pairs, so the force applies. The apple must meet equal opposite. The normal force is, if you will, the reaction force. Hello, where'd my pen go? The reaction force, all right? And then it's also put in third law, right? All right, the force has been equal and opposite. So in the context, the normal does not mean regular or ordinary. In math, in physics, normal actually means perpendicular. So normal doesn't mean ordinary, right? Or, if you will, the normal force acts, if you will, at a 90-degree, perpendicular, right, angle on the surface of the object that it's on. So that's important to understand. You're gonna get more of this as we kind of figure this out. So let's draw 3 pictures. We've got 3 apples. What is the force? There's the force of gravity acting downward. Gravity always acts downward. So the force upward, since it's not moving, we call that the force normal, the normal force. Does that make sense? So it has to be equal and opposite. My arrows maybe aren't quite exactly the same length. They should be. All right, what about this case right here? All right, we've got the second apple. We still have the force of gravity, all right? But the normal force is perpendicular to the, if you will, the force that's being applied to the object. All right, let me change the color here so we can see this. It's going to be off at this direction. This is the force normal. It's perpendicular to this surface, right? This is the 90-degree angle with respect to the board or the table or whatever that it's on. And the same ball game is going to happen here. This is the force of gravity, all right? But what's the normal force going to be? It's going to be coming out perpendicular, again, to the board. And this is the normal force, perpendicular to the board. So you're going to discover, obviously, we're going to be dealing with ramps and cool stuff like that, and then we're going to have angles. So the normal force is the force perpendicular to the surface that you are on. Make sense? All right. So it turns out then that this normal force is a compensator of forces. It provides the surface is strong enough to withstand the force applied to it. So if we go back to our picture right here, if we were at an angle in particular, you might think that the apple is going to fall and accelerate in this direction. It might, but if the force, if you will, that's here, right, which we'll learn about is called friction, is big enough, it can't overcome. The apple, in theory, might be able to stay on the incline, depending on the material that it's made out of and a variety of things, right? So the normal force will be, if you will, let me back up here. if it's strong enough to withstand the force applied to it, the normal force will increase. This is important. As the force applied increases. Which leads us to kind of like a thought experiment. If you place your binder or book on a desk, right? So I got a book right here. I'm going to put my book on the desk. I'm going to rest my hand on it. That's step one. Or, right, I can apply a much greater force to the book. Does my binder accelerate through the desk? All right? Of course it doesn't. So that means that the forces must be balanced. Because in the first case, I'm just resting my hand on the book. In the second case, I am pushing hard on the book. So let's think about it. Let's draw a picture. Let's force it, our force body diagram, our free body diagram. So we've got a book. It's on a table. Of course, there is the normal force, or pardon me, the force of gravity on the bottom. But there's also, if you will, because my hand is resting on it, there is also the F of the hand being pushed downward. So the normal force would be the sum of these two forces. Make sense? But what if I was pushing really hard on the table, right? This is the force of gravity. Actually, that was G right here. And I'm going to be pushing super hard in it, the force of the hand. And then the normal force is much higher. It's going to be the sum, honestly, of the two forces. Because since the book is not accelerating. So even though you have two situations and the book still doesn't move, this is weird, I know. In one case, the force is going to be, the normal force, will be much higher because the force pushing back is just as strong. Again, this goes back to what we said in an earlier segment where I said when my professor, the Swedish professor in college, he said, when they push on the table, is there a genie pushing a back? No, what's happening, of course, is that the table is pushing back. And if I push hard on the table pushes back harder. That is, unless I can accelerate it. But in most cases, you can't accelerate a table by pushing down on it. In the next segment, we're going to start looking about how to do solves and the maths of this stuff so that we kind of figure out how the normal force works mathematically. But that's sort of the big picture. It's the perpendicular force, usually opposed to gravity, on an object. Houston, we have no problems. We'll see you in class.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.